Hello friends, today we'll solve the GATE 2025 Electronics and Communication paper device physics section. Okay, so there are 5 problems, so we'll discuss each one of them one by one. So first of all is like which of the following can be used as an n-type dopant for silicon. Okay, so the correct answer is arsenic and phosphorus, because when we look into the periodic table, then like group 3 or group 13 of p block, so this boron, aluminum, gallium, indium, these things are like p-type dopants. These can be used as p-type dopant, and these group 15 element, which is like phosphorus and arsenic and antimony, these can be used as n-type dopant. Okay, so these are the semiconductors, so they give one extra electron and they give one extra hole. So this was the first question. These are p-type dopant, these are n-type dopants. And the second question, again on basic device physics, the intrinsic carrier concentration of a semiconductor is given, and electron and hole mobilities are given, and the intrinsic resistivity of the semiconductor we need to find out. So intrinsic resistivity is 1 upon the conductivity of the semiconductor, which is basically 1 upon nq, and then the total mobility mu n plus mu p, because it has both electron and hole mobilities are given, so mu n plus mu p. And so just we need to put the value. So this is q is 1.6 into 10 raised to power minus 19 coulomb, ni is 2.5 into 10 raised to power 16, and when we add this, then 0.15 and 0.05, we need to add both of them. Okay, and so when we just simply solve this thing, this denominator part, we get 8 upon 10,000. So the intrinsic resistivity is 1 upon 8 upon 10,000, so this is like 10,000 upon 8. Okay, so this part is 1.25 and this is kilo ohm, so this is 1.25 kilo ohm meter. Okay, so B is the correct answer. Now we come to another question, which is like the electron mobility mu n in a non-degenerate germanium semiconductor is this, and electron diffusivity we need to find out. So here it's a direct question on Einstein relation, which is like d over mu is kt over q, so which is valid for both dp upon mu p and dn upon mu n is equal to kt upon q, which is like thermal voltage, which is equal to 0.026 volt at 300 Kelvin room temperature. Okay, so here the catch is that we need to find diffusivity in centimeter square per second, while this value is given in meter square per volt second. Okay, electron mobility. So what we will do is, we will mu n is given, so dn will be mu n into vt. So this is mu n, and we first need to convert it into centimeter square, so this will be 100 centimeter square, because 1 meter is 100 centimeter. Okay, so dn is basically 0.026, so this is like 226 upon 1000 into this is like 38 upon 100, and then this will be equal to into 100 square. So once we solve it, okay, we get 98.8 centimeter square second. Okay, so B is the correct answer. Fourth question is like on, again very basic question, like electric field is applied to a length of copper wire of circular cross section of diameter 1 mm. Copper has conductivity of this thing, so the current flowing through the wire is, so we know that J is equal to sigma E, Ohm's law. Okay, so this is current density is equal to conductivity times the electric field. Now current density is current per unit cross sectional area, so current will be cross sectional area into conductivity times the electric field. Now cross sectional area of the wire will be pi r square, so pi into, so diameter is 1 mm, so we'll put it 0.5 into 10 raised to power minus 3 into square. Okay, because it is like millimeter now, so that's why we'll put 10 raised to power minus 3. Now I will be equal to, this value is given to us 5.8 and to 10 raised to power 7. Okay, and then this is 0.01 upon 1000, and this part is like 1 by 2 into 10 raised to power minus 3 1 by 2 into 10 raised to power minus 3 and pi. So once we solve it, we get again this value is equal to 0.46. Okay, so you can see the calculation. And there is like one last question which is on diode current equation. So it says that an ideal PN junction diode has reverse saturation current of 10 microampere at 300 Kelvin. So the voltage to be applied across the junction to get a forward bias current of 100 milliampere is Kp value is given. So how we will solve it? So you can see that diode current equation is basically reverse saturation current Is into e raised to power v upon eta Vt minus 1. So this is ideal diode and it's also germanium diode, so eta is 1. Okay, so basically it will be, so we need to find this voltage V. Okay, so we will put id upon Is and then we'll take this one on left side. So this is id upon Is plus 1 equal to e power V upon Vt. So V upon Vt is ln of id upon Is plus 1. Okay, now once we solve this part, so this is ln of I is 100 into 10 to the power minus 3 upon 10 into 10 to the power minus 3 plus 1. Okay, so here 10 to the power minus 3 10 to the power plus 1. So this is equal to ln of 10 to the power minus 1 into 10 to the power 5 plus 1. Okay, so this is 10 to the power 4 plus 1, so which is like 10,000 plus 1 is like 10,000. So ln of 10 to the power 4 is 9.210, and then we will multiply this thing with Vt. So once you multiply this thing with Vt, we get the answer as 0.024 volt. So these were the all 5 questions of this semiconductor device physics part. Thank you.